We're talking about exponential growth and decay functions. And we want to graph exponential growth functions and graph exponential decay functions. So in the past, we've looked at graphs that have been y equals ab to the x, but now we're adding in a negative h and also a plus k. The h shifts the graph horizontally, and the k shifts the graph vertically. The k is also the horizontal asymptote, so y equals k. So that's going to be a very important thing because that's going to be the point where our graph gets very close to but does not touch. So every time we want to make sure that we locate our asymptote. In this case, we have our a value is 3, our b value is 2, our h value is -1. It's negative because the h here is negative, so in order to get that positive, it has to go backwards. And the k value in this case, there's no k value here, so it's understood that we have a k value that's equal to 0. So k is equal to 0, so that means our y asymptote, or our asymptote, is going to be y equals 0 for our asymptote. So I know that my graph is going to get very close to 0, but it's not going to touch 0. So I can draw that y equals 0 on my graph. So that's that line down here. So that's y equals 0. Now the next thing we want to do is we want to pick out a couple points that are going to be easy for us to plot. And in this case, when we're looking at our exponent, we want to get our exponent that's close to 0, 1, or 2. So even to make sure that those are even easy for us to graph. So when we are looking at this, we're going to set up x and y axis, but we're going to set it up a little different than we're used to. So we're still going to have the x value, but we're going to set up our y value a little different. So our x value in this case, we want to pick numbers that are going to make our exponent close to 0, 1, or 2. So if we think about this, how could x plus 1 become 0? That would be if we picked -1 for our x. So we're going to substitute -1 into the equation. So then that's going to be equal to 3 times 2, and then we're going to substitute in -1 plus 1. So -1 plus 1. So if we do this math here, we get -1 plus 1 is 0. So then we get 3 times 2 to the 0 power. Then we can use our exponent rules. Anything to the 0 power is always 1. And so when we get our y value 1 times 3, our y value is equal to 3. So we get the ordered pair -1, 3. So we can plot that point. -1, 3. Then I want to pick my next point, which in this case is going to be 0. So I'm going to substitute in 0 into the equation. And that's going to be equal to 3 times 2 to the 0 plus 1. So what's 0 plus 1? That's going to be 1. So 3 times 2 to the first. 2 to the first power is 2. 2 times 3, that's equal to 6. So we have the ordered pair 0, 6. So 0, 6. And if we get one more, that will be good enough for us to graph our function. So again, I'm going to pick the next point, which is going to be 1. I'm going to substitute that in. So it's going to be 3 times 2 to the 1 plus 1. 1 plus 1 is 2. So it's going to be 3 times 2 squared. 2 squared is 4 times 3. That's equal to 12. And so we have the ordered pair 1, 12. And then we can kind of figure out where the rest of the points are from that. So to go from this point to this point, vertically, this is 1, 2, 3. So we're going up 3. And to get from this point to this point, 1, 2, 3, 4. Oh, I graphed the wrong point. It should be 112. 1, 2, 3, 4, 5, 6. So this is up 3, then 6. Then the next one's going to be up 12. Well, that's off the graph. But we can do the same thing going the opposite way. So it goes 6. Half of 6 is 3. Half of 3 is 1.5. So we're going to go over 1, down 1.5. And half of 1.5 is 4/3. And then at that point, we're pretty close to just getting a great graph of our exponential growth. And we'll just draw it so it goes through those points.